Ever wondered how Docker simplifies deployment across varying environments? Let's find out. Docker at its core is a platform that allows developers to package applications and all their dependencies into standardized units called containers. These containers ensure that applications run smoothly and consistently, regardless of the environment they're deployed in, be it your local machine, a test server, or a cloud-based production environment. Why is this important? Well, think of it this way. You're a chef preparing a gourmet meal. To ensure that the dish tastes the same every time it's served, you need to follow a specific recipe, using specific ingredients in specific quantities. That's what Docker does for software. It provides a recipe in the form of a Docker file that describes exactly what components an application needs to run correctly. This includes the operating system, libraries, environmental variables, and so on. Once you've created a Docker file, Docker can use it to build a container image, a lightweight, standalone, and executable software package that includes everything needed to run a piece of software. This container image can then be run locally on your machine or pushed to a Docker registry, from where it can be deployed to any environment that supports Docker. Let's take a look at some code to see how this works in practice. To create a Docker container, you first need a Docker file. Here's a simple example of a Docker file for a Node.js application. Once you've written your Docker file, you can use the docker build command to create a Docker image and the run command to start a container from that image. Managing Docker images and containers is also straightforward. The docker ps command lists all running containers, the images command lists all locally available images, and the rm and rmi commands can be used to remove containers and images respectively. That's Docker in a nutshell, a powerful tool for packaging applications consistently. By containerizing your applications with Docker, you can ensure that they'll run the same every time, no matter where they're deployed. Now it's time to explore the vast landscape of AWS. Amazon Web Services, or AWS as we know it, offers a plethora of services for hosting our Docker containers. From Elastic Compute Cloud, better known as EC2, to Elastic Container Service, or ECS, the possibilities are vast and varied. Let's delve into the specifics of these services and how we can leverage Python to automate the creation of AWS resources. EC2, a fundamental AWS service, provides scalable computing capacity. It allows us to create virtual machines, commonly referred to as instances, in the cloud. Now imagine creating hundreds of these instances manually. Quite a task, isn't it? But not to worry. With Python's Boto3 library, we can automate this process, making it as simple as running a script. But that's not all. AWS also provides Virtual Private Cloud, or VPC, which lets us provision a logically isolated section of the AWS cloud. Here we can define our virtual network, complete with subnets, route tables, and network gateways. Once again, Python comes to our rescue. Using Boto3, we can automate the creation and configuration of our VPC, ensuring a secure and efficient networking setup. And let's not forget about security. AWS has us covered with security groups, essentially virtual firewalls that control inbound and outbound traffic for our instances. And yes, you guessed it, Python and Boto3 can automate this too. With just a few lines of code, we can define our security rules and apply them across our infrastructure. Finally, we have ECS, a highly scalable, high-performance container management service. It allows us to run, stop, and manage Docker containers on a cluster of EC2 instances, and with the magic of Python, we can automate the deployment and management of our containerized applications on ECS. So there you have it. We've just navigated the AWS ecosystem, set up our infrastructure, and seen how Python can automate the process, making it more efficient and less error-prone. With AWS set up and ready, we're all set for the next step. Ready for some magic? Let's integrate Docker with AWS. When these two powerhouses come together, we can achieve seamless application deployment, and with Python automation scripts, we can make this process even smoother. Let's start with ECS, the Elastic Container Service. This AWS service is tailor-made for Docker, allowing you to run, stop, and manage Docker containers across a cluster of Amazon EC2 instances. With Python's Boto3 library, we can automate the creation of an ECS cluster, define task definitions for our Docker containers, and even manage service scaling based on demand or schedule. But where do we store our Docker images? Enter ECR, the Elastic Container Registry. This fully managed Docker container registry makes it easy to store, manage, and deploy Docker container images. And guess what? We can automate the entire process of pushing Docker images to ECR using Python. With just a few lines of code, we can authenticate our Docker client with ECR, tag our local Docker image, and push it to the registry. Now let's bring this all together. With our Docker images in ECR and our ECS cluster ready, we can automate the deployment of our Docker containers to AWS. Our Python script will update the ECS service with the new Docker image, manage the desired count of running containers, and even handle rolling updates to minimize downtime. But our job doesn't stop at deployment. We need to monitor our application's performance and manage cluster scaling. AWS CloudWatch provides detailed metrics for our ECS services and tasks. And with Python, we can automate the process of fetching these metrics and making informed scaling decisions. So there you have it. By integrating Docker with AWS and leveraging the power of Python automation, we've transformed a complex task into a streamlined process. With Docker and AWS working in harmony, application deployment is as easy as pie. Let's supercharge our workflow with CI/CD. In the world of software development, continuous integration and continuous deployment, or CI/CD for short, is the backbone of any efficient and effective workflow. But what exactly is CI/CD? It's a method where developers integrate their work frequently to the main branch, usually several times a day. This practice allows teams to detect and locate errors quickly and reliably. Once the updated code passes all automated tests, it's deployed to production automatically. This means more frequent releases, faster feedback, and less time spent on fixing bugs. Now imagine coupling this powerful approach with the automation capabilities of Python. That's right. With Python, we can automate the entire CI/CD pipeline, making the process even more streamlined and efficient. Let's take Jenkins, a popular open-source automation server. Jenkins can be used to automate parts of the software development process with continuous integration and facilitating technical aspects of continuous delivery. Using Python, we can write scripts that automate the build, test, and deployment processes in Jenkins. But Jenkins is not the only tool at our disposal. AWS Code Pipeline is a fully managed continuous delivery service that helps you automate your release pipelines for fast and reliable application and infrastructure updates. And guess what? We can automate AWS Code Pipeline with Python too. By writing Python scripts, we can define the entire pipeline from source control, build, and test stages to deployment. We can create and manage resources, trigger pipeline executions, and even handle errors and exceptions. This level of automation not only saves time, but also ensures consistency and reliability in our deployments. In a nutshell, automating your CI/CD pipeline with Python means more time for innovation, less time spent on repetitive tasks, and faster delivery of high-quality software. Congrats, you've just automated your CI/CD pipeline with Python. Before we wrap up, here are some best practices and tips. When deploying Docker containers on AWS, always consider resource allocation. Be sure to allocate sufficient resources to your containers, but avoid over-provisioning to save costs. Next, let's talk about security. Always follow the principle of least privilege. This means granting only the necessary access rights for a task. It's also a good idea to regularly update your Docker images and AWS services to benefit from the latest security patches. Now, on to monitoring. Regularly check the performance of your containers and the usage of your AWS resources. This way you can quickly identify and address potential issues before they escalate. And lastly, don't forget the importance of backups. Regularly back up your data and configurations to quickly recover in case of any failures. Remember, knowledge is power. Use these tips to deploy robust and scalable applications. Wow, what a journey it's been. We've navigated through the intricate maze of Docker, AWS, and Python automation, unlocking the secret to seamless application deployment. We started with understanding Docker, the incredible tool that packages applications into neat little containers, ensuring consistency across environments. Then we ventured into the vast AWS ecosystem, using Python to automate the creation of necessary resources. The magic truly began when we integrated Docker with AWS, deploying containers, managing clusters, and monitoring performance, all automated with Python. And let's not forget the cherry on top, achieving continuous integration and continuous deployment, automating the build, test, and deployment processes. Along the way, we've shared industry best practices and tips to optimize your Docker deployments on AWS. Congratulations! You've mastered Docker with AWS Automation using Python. You've harnessed the power of these technologies to streamline your development workflow and reduce operational overhead. Don't forget to like, share, and subscribe for more awesome content. Until next time, happy coding.